Hi everyone, Adarsh here. So this is a continuation series of JDK8 stream where we in the earlier sessions we have seen about the sequential stream as well as the parallel streams. So we have seen that when we execute the sequential streams in the sequential way, only one thread will work on the elements to process the data. But while on the other hand, when we do processing parallelly, then we have seen that we have a multiple threads operating on the streams on the data on processing the data elements. So in this session we're gonna see how we can increase the number of thread counts for processing the parallel streams. So first we have a here's the example, here's a code which gonna get you the uh, pool parallelism count. So basically the number of threads which are available for processing the data. So in the sequential way, anyhow we knows that only one main thread is responsible for processing all the data elements. So here you can see that only one as well as only the main thread which is processing the data into the sequential way. But if we talk about by default, we have only one thread which does this operation basically. So here we can see that in the as of now only one thread is available to process the whole data. So basically the one thread is something which is worker thread as well as the main thread. So though both the threads are parallelly processing the data, so that's why you can see that 6 and 7 are processed by the main thread. After that, worker thread has taken up all the data elements to process it. But how we can increase the number of count in the thread? So for that we need to pass this VM argument which is -d java.util.concurrent.fork.join pool.common.parallelism and the number of count. So I'll just give here it based on the ID. You can pass it in Eclipse, it's a different way, in NetBeans it's a different way. So earlier we got one here, now we need to see how much difference it's gonna do. And in the earlier example we have seen that only worker 1 is executing, but we have given an upper bound that 5 threads can do the processing here. So let's see the difference here. So here you can see that 5 threads are available. Okay, let me execute because it will cache, the result will cache in the ID. So here you can see that 5 number of threads are available for processing, parallel processing. So here you can see that main thread has processed 6 7 element as well as 9 element. Worker thread 1 has processed 8 number, worker thread 3 has processed 2 number, worker thread 2 has processed 5th element, and worker thread 4 has processed 4th element, worker thread 5th has processed 10th element, worker thread 5th has processed 1st element, and worker thread 1st has processed 3rd element. So that's a proof that we can increase the number of threads, number of parallel threads in parallel stream processing, so which gonna reduce the processing time and improve the performance very drastically. And there will be a major difference in the processing time as compared to sequential to the parallel. So that's it for this video, that's it for this session. I'm gonna give you some more knowledge in my coming video tutorial. So please do subscribe my channel, share your thoughts, comments if you have something. And for this video that's it, and I'll come up with something new and interesting related to parallel streams in my coming video tutorial. Till then, take care, bye.